Hello everyone, welcome to Equal To, and this is episode 16 of our Polynomials playlist, and here we are at the last question of exercise 2.3, and this is similar to the previous question that we solved in the previous video. So I'm just going to factorize the polynomial, but the difference is that in the previous question we factorized a quadratic polynomial, meaning the degree of the polynomial was 2, but in this case the degree of the polynomials are 3. Okay, they are cubic polynomials. We have 4 questions or 4 subdivisions in this question, and all these 4 subdivisions are cubic polynomials. Okay, now we have solved one example question which is a cubic polynomial, and we are going to use the same approach to solve these questions as well. Okay, so I hope you have watched that already. Like we will be just using the same concept here. Okay, so what do we use to do? We just find 1 0 of this polynomial by brute forcing, right? So what do I mean by that? We find 1 root or 1 0 of this polynomial by trial and error. Okay, so by trial and error in the sense you are just going to put random values in the value of x, and you're going to see if that comes out to 0. If that comes out to 0, then that is a 0 of this polynomial, right? So let us just say if p of 1, let us find the value of p of 1 and see if it comes out to 0, right? So x cube 1, so that will be 1. So minus 2 into x squared, so x squared is 1, so it's just minus 2, and then we have minus x, so that is minus 1 and a plus 2. Okay, so these 2 gets cancelled and this gets cancelled, so this comes to 0, right? This was easy for the first question, but doesn't mean to be true for the others as well. So p of 1 is equal to 0. So by factor theorem you can tell that x minus 1 is a factor. Okay, so that is what factor theorem says, right? Since p of 1 is equal to 0, x minus 1 is a factor. Okay, I'm just erasing these things. So I'll have this written at this side, x minus 1 is a factor. Okay, now we are going to proceed with that. Now we are going to take this x minus 1 as a common factor from all the terms in this polynomial. Okay, so for that you are going to rearrange this in such a way that it's easy for you to take x minus 1 as a common factor. Okay, so from the first 2 terms you cannot take something so that it becomes x minus 1, right? So what I am going to do is, if you want to make this x cube as x minus 1, or rather x, you'll have to take x square as a common factor out of it, right? And if you want to take x square out of it and you want the next term to be minus 1, then the next term should be minus x squared. Okay, let me just repeat this once again so that it's clear for you. Only if we have x cube minus x squared, only in this case when you take x squared out of it you will get x minus 1, right? We need x minus 1 from the first 2 terms, because that is how you can take it as a common factor, right? All terms must have x minus 1. That is how you can take x minus 1 as a common factor, and we want x minus 1 from the first 2 terms. So for this to become x minus 1, we need to take x square out, and that should become x minus 1. For that to occur, the term should be x cube minus x squared, but here we have 2x squared, so we are going to rewrite this as x squared minus x plus 2. Okay, so all we have done is we have rewritten minus 2x squared as minus x squared minus x squared. We have just split it and written as 2 separate terms, minus x squared and minus x squared. And please follow with me. So at the end of this question you will understand this very well. Okay, so if you haven't got this cleared yet, please bear with me for a while, you will understand it very clearly. Okay, now from the first 2 terms you can now take x squared as a common factor, and that leaves you with x minus 1. Okay, you can take x squared from these 2 terms, x squared minus x cube minus x squared. From this you are taking x squared as a common factor, and that leaves you with x minus 1. Okay, so this is what we have done all this stuff for. Okay, for this to occur, Now these two terms have become one term and we have x minus 1 as a common factor. So we can take that entire x minus 1 from all the terms. Just for that we are doing all these things. Okay, so this is what we have done for the first two terms. Now we have the next two terms, right? Minus x squared and minus x. We also again want a x minus 1 out of it. Okay, so what we are going to do is, we are having this minus x squared, we are not going to do any change for that. We are going to rewrite this minus x as minus 2x plus x plus 2. Okay, we have just rewritten this minus x as minus 2x plus x. Minus 2x plus x is equal to minus x, right? Now why have we done this? Okay, in the next step that will be quite clear for you. Now you can tell that plus x minus 2x plus 2. Okay, I've just rearranged these two terms. My x has come here and minus 2x has gone there. So this allows you to again factorize it further, like you can take minus x out of these two terms and that gives you x minus 1 here. Okay, you have taken minus x out of these two terms and that has given you x minus 1. So the entire point for you doing all this is you are going to convert it into x minus 1 and into some other things, right? So when it is x minus 1, that is what we want, because we know x minus 1 is a factor and you can take that x minus 1 entirely out after you are done with it. Okay, now for the next two terms you can take minus 2 as a common factor and that gives you x minus 1 as well. Now you can see we have come a full circle. Now we have x minus 1 in all three terms. So these are the three terms in our polynomial now, and we have x minus 1 common in all three terms. So you can take x minus 1 as a common factor outside and that leaves you with x squared minus x minus 2. Okay, all the steps and all the things that we have done so far is for you to arrive at this equation. Okay, now we have taken x minus 1 as a common factor and we are left with x squared minus x minus 2. Okay, so basically you are trying to rearrange these terms so that it comes out to x minus 1 into some other polynomial. Okay, now this might be quite confusing for you. Please bear with me. I'll explain it once again in the next three subdivisions as well. So by the time we complete this question, it will be very clear for you. Okay, now after this, we have just factorized the first term, right? We have x minus 1. We still have the other terms. Okay, it just converted into a curve. Okay, now we are going to factorize this x squared minus x minus 2. This is a piece of cake for you because it's just splitting the middle term method, which we know already. So it's going to be minus 2 and minus 1 here. We have solved tons of questions on this, right? It's quite easy for you now. So basically 2 and 1 gives you 2 and you have minus 2. So either of these numbers should be negative, and minus 2 plus 1 gives you minus 1, right? So minus 2 should be there. So x squared plus x minus 2x minus 2. And from this first two terms you can take x as a common factor and that leaves you with x plus 1. And from the last two terms you can take minus 2 as a common factor, that leaves you with x plus 1 as well. From these two terms you can further take x plus 1 as a common factor and we have x minus 2. Okay, now we are going to replace this instead of this one here. Okay, so the final answer that you can write to be, I'll just increase the size of this, x minus 1 into x plus 1 into x minus 2. Okay, so that is the factorized form of this cubic polynomial, which is x cube minus 2x square minus x plus 2, and this is the answer. This is the factorized form. Okay, so we have solved this. We first found one factor, that is by using trial and error, and then we have just basically rearranged the terms and we have split it according to our interest, and we have taken this x minus 1 as a common factor. So after finding this common factor, all you think of is how you can take that common factor from the terms that are present there. Okay, So that is what you have done, and that is how you come up with the answer. Now please bear with me, we will be solving other questions as well in the same question, other subdivisions as well, so this concept would get very clear for you. So basically starting with the first step. The first step is, by using trial and error, you are going to find 1 0 of this polynomial, and with that you can, using factor theorem, you can tell the first factor as well. Okay, so let us find, let me just reduce the thickness. P of 1, okay, P of 1 is equal to 1 minus 3 minus 9 minus 5, right? So this doesn't come up to 0, so 1 is not a 0 of this polynomial. Let us say check that for minus 1, so that is equal to minus 1 cube is minus 1, and minus 1 squared is plus 1, so this becomes minus 3, and this becomes plus 9, and we have minus 5 here. So this is minus 4 minus 5 plus 9, so that comes out to 0. Okay, so P of minus 1 is a factor. P of minus 1, since it is equal to 0, you can tell that minus 1 is a 0. Okay, so x plus 1 is a factor. Okay, I hope you are clear with that now. This is very easy. This we know already. We have solved so many questions on this same itself. Okay, so this x plus 1, it's a factor, so I am going to have this aside. Okay, now the same procedure we are going to do. We are going to split this polynomial in such a way that you are going to take this x plus 1 as a common factor from all these terms. So that is going to be your basic idea. Okay, so let us first take these first two terms. I'm just going to rewrite them here. Zoom in a little bit. X cube minus 3x squared. Okay, let us just consider these two terms now. In these two terms, if you want to express this in terms of like, okay, I am so sorry. Okay, so you have to express this in terms of x plus 1 into something. Okay, you want to express it in that way. Okay, so that should be your idea. Now here we have minus 3x squared, right? When you have minus 3x squared, how can you express it in form of plus 1, right? Whatever you take common out, you have minus 3x squared, so it would come up to be a negative term, right? So what you are going to do is, you are going to rewrite this minus 3x squared in a different way. What can you do? You can write this as minus 4x squared plus x squared, right? We have just taken this term minus 3x squared and you have split it in two parts, so minus 4x squared and plus x squared. Now what you can do is, you can rearrange this like x cube plus x squared minus 4x squared. I've just swapped these two terms position. Okay, now if you see the first two terms, you can take x square as a common factor, and that leaves you with x plus 1 and minus 4x squared. Okay, so this is the basic idea, and this is what you are going to do repeatedly. Okay, so this is what you are going to do repeatedly until all the terms in this polynomial have x plus 1 as a common factor, and you can take that out finally. So we have these terms, and we are going to write the rest as well here. So what are the rest two terms? These are the two terms, right? Okay, so adding them as well, we have x squared into x plus 1 minus 4x squared minus 9x minus 5. Okay, again we can take the next two terms. This term here, this is sorted. Okay, this is done. We need what we want from it, that is there, so you don't have to worry about this now. Let that sit aside and you can work with the other terms that we have. Let us take the next two terms. The next two terms are 4x squared minus 9x, and you want to take x plus 1 as a common factor out of it. Okay, so if you take minus a 4x squared, what should be the next term, so that you can take 4x out and it becomes x plus 1, right? So for it to become x plus 1 and you have to take minus 4x out, you just need minus 4x, right? When you take minus 4x out of minus 4x, it becomes 1, and 1 is what we want because that is x plus 1. So you are just rewriting this minus 9x as minus 4x and minus 5x. Okay, now from the first these two terms we have expressed this as these three terms. Okay, we have just split this minus 9x into minus 4x and minus 5x. Okay, now from the first two terms you can take minus 4x as a common factor and that leaves you with x plus 1, and the next term can remain that way itself. Okay, minus 4x into x plus 1 and minus 5x. So that is what we have done now. Now I'm just going to rewrite this here. We don't have enough space now. Okay, so x squared into x plus 1 minus 4x into x plus 1 minus 5x minus 5. Now we have two terms that don't have x plus 1. Okay, the next thing that we are going to focus on is how we can bring x plus 1 to those two terms. So that is going to be very simple, as you can see and you have guessed already. These two terms have minus 5 as a common factor. So minus 5, if you take it out, that becomes x plus 1. Now as you can see, all these three terms has x plus 1 as a common factor. So you can take that x plus 1 outside as a common factor and that leaves you with a quadratic polynomial, that is x squared minus 4x minus 5. Okay, and till this is the crucial part. After this, it's going to be a breeze for you. It's going to be very easy to solve this from now on. Okay, so let me just move this aside. Okay then, so we have x plus 1 into, I'll just zoom in after writing x plus 1 into x squared minus 4x minus 5. Right, we are just going to simplify this quadratic polynomial, that is by using splitting the middle term method that we know. So the product should be minus 5 and the sum should be minus 4. 5 into 1 is 5 and we need minus 5. So one of this should be negative. If minus 5 is negative, 5 is negative, then minus 5 plus 1 gives you minus 4. So that is a viable option. So x plus 1 into x squared plus x minus 5x minus 5. Okay, I have written it in this form so that you can take the common factors out easily. So x plus 1 into, if you take x from the first two terms, that gives you x plus 1, and if you take minus 5 from the next two terms, that gives you x plus 1 as well. Okay, now from all these three terms you can take x plus 1, we have x plus 1 here, and inside these two terms you can take a x plus 1 out and that leaves you with x minus 5. Okay, so x plus 1 into x plus 1 into x minus 5 is the factorized form of this polynomial. Okay, so this is the answer. Let me just write it boldly here. So x plus 1 into x plus 1 into x minus 5. Okay, so that is the answer to this question. So I hope you have got some idea. If you are still confused, we can look at two more examples as well, two more subdivisions from this question. So the idea remains the same. You find 1, 0 and you try to take that factor as a common factor out of the polynomial and convert it into a quadratic polynomial, and then you can solve easily. Okay, converting it into a quadratic polynomial is the difficult part. After that, it's very easy. Okay, now moving on to the next subdivision. I think by now you would have got some idea of it. Now we can try to solve this a little bit faster. Okay, we're going to see if p of 1, I will just make this a bit smaller. Okay, we are just going to see if p of 1 is equal to 0. So 1 plus 13 plus 32 plus 20, all are positive terms, it can never be 0. So we can take p of minus 1. So that is minus 1, and we have plus 13, we have minus 32 plus 20. Okay, so minus 1 and plus 13, that comes out to minus 12. We have that comes out to plus 12. We have 20 minus 32, so that comes out to 0. So minus 1 is a 0 of this polynomial. You can tell that x plus 1 is a factor. Okay, now you can tell that x plus 1 is a factor of this polynomial. Okay, now we can try to convert this polynomial in such a way that it's expressed as a quadratic polynomial into x plus 1. Okay, so from the first two terms you can take you want to take x plus 1, right? So you are going to write it as x cube plus x square plus 12x squared plus 32x plus 20. Now since I have split this 13x squared as x squared plus 12x squared, from the first two terms you can take x squared as a common factor, and that leaves you with x plus 1. Now we are going to the next two terms. You have 12x squared and 32x. Okay, we need to take 12x out of it, only then it would become 12x into x plus 1, right? So for that you are going to rewrite this as 12x squared plus 12x plus 20x plus 20. Since we need 12, we have taken 12 out of it, and that gives you 20 as well. So 12x plus 20x, that is equal to 32x. You have split that and written it like this. Okay, now in the next step we are going to take that common as well. So 12x squared plus 12x, if you take 12x as a common factor, that gives you x plus 1. And in the last two terms, if you take 20 as a common factor, that gives you x plus 1 as well. Now from all these terms you can take x plus 1 as a common factor, so that leaves you with x squared plus 12x plus 20. Okay, now we just have a quadratic polynomial that can be solved using splitting the middle term method. Low battery. Okay, so the product should be 20 and the sum should be 12. So 10 times 2 is 20 and 10 plus 2 is 12, so that is a viable option. So x plus 1 into x squared plus 2x plus 10x plus 20, x plus 1 into, from the first two terms you can take x as a common factor, so that leaves you with x plus 2, and in the next two terms you can take 10 as a common factor, that leaves you with x plus 2 as well. Okay, so this should be a plus. Sorry, this should be a plus. I have done it wrongly. Okay, so x into x plus 2 plus 10 into x plus 2. Now you can further write straight away the answer. I am just making it bold. So x plus 1 into, from the next two terms you can take x plus 2 as a common factor, and that leaves you with x plus 10. So that is the factorized form of this polynomial, and that is the answer to this question. Okay, so we can do it fastly if you are just if you just understand this concept a little clearly. Okay, moving on to the last subdivision. Here we have y instead of x, so it's basically the same, nothing different here, just a different variable. Okay, let us check for p of 1. So that is 1 cube, that is 1, and plus 1 minus 2 minus 1, that equal to 0. Okay, so 1 is a 0 of this polynomial, so you can say that x minus 1 is a factor to this polynomial. Okay, x minus 1, sorry, it shouldn't be x minus 1, it should be y minus 1. Why? Because y is the variable that we have here, right? So y minus 1 is a factor of this polynomial. So we are going to try and take y minus 1 as a common factor. Okay, so 2y cube we have. For you to convert it into y minus 1, we need 2y, right? And it should be minus 2y. Okay, so we can take 2y squared out of it, and it should become, if you take 2y squared out of it and it want you to become y minus 1, so you can basically multiply it and see. So it should be 2y cube minus 2y, right? We already have 2y cube here in the question, so we just need minus 2y squared, right? It should be minus 2y squared. I'll just defend the mistake. Okay, so 2y cube minus 2y squared. How do we do that? You can just split this y squared and write it as minus 2y squared plus 3y squared. Okay, so minus 2y squared plus 3y squared, when you add it you will get y squared, and then we have the next terms as well, minus 2 minus 1, minus 2y minus 1. So from the first two terms, if you take 2y squared as a common factor, you are left with y minus 1. Okay, I'm just writing the next terms here as such. From the next two terms, if you want y minus 1, you are going to rewrite them as well as 3y squared it is minus 3y plus y minus 1. So minus 3y plus y is minus 2y, right? We have just rewritten this minus 2y as minus 3y plus y. Okay, so 2y squared into y minus 1, and from the next two terms you can take 3y as a common factor, and that gives you y minus 1 as well, and from the last two terms you can take 1 as a common factor, and that gives you y minus 1 as well. Now if you take y minus 1 as a common factor from the entire polynomial, that gives you 2y squared plus 3y plus 1. Okay, now you just have a quadratic polynomial to worry about. 2y squared plus 3y plus 1, and that should be a piece of cake for you. Splitting the middle term method, so the product should be 2 and the sum should be 3, so it's just 2 and 1. So you can write 2y squared plus 2y plus y plus 1. You can take 2y as a common factor from the first two terms, that leaves you with y plus 1, and you can take 1 as a common factor, that leaves you with y plus 1 as well. You can take y plus 1 as a common factor, and that gives you 2y plus 1. Okay, now this is the value of the quadratic, like factorizing the quadratic polynomial. So the final answer that you can write as y minus 1 into y plus 1 into 2y plus 1, 2y plus 1, and that is the factorized form of this polynomial, and that is the answer to this question. Okay, I hope you have understood this. I know this is quite a lot, and I am not blaming you if you don't understand it the first time. We have solved 4 questions here, and we also solved an example question previously for cubic polynomial. If you haven't understood it clearly, please feel free to go through this once again and try to solve this along with me. Like maybe pause the video every once in a while and try to solve this along with me. By that you can understand this very clearly. It's not a difficult thing, but it's quite tricky. So that is it. So if you have any questions or any doubts, please feel free to put them in the comments. I'll get back to you as soon as possible. Thank you so much for watching this video. See you in the next video. Bye for now.